Welcome to the lesson overview 4.02 Trigonomic Ratios Part 1. We're going to determine specified trigonomic ratios given the side lengths of a right triangle, and we're going to define trigonomic ratios for acute angles. There's two snips you'll need in this video, so go ahead and pause now and take a snip of this screen. It is important to know the hypotenuse side, the opposite side, the adjacent side of a right triangle. The hypotenuse is always the longest line, and it's across from the right angle. It never changes its name. The opposite and adjacent side, however, do change their sides. So if you look here, you see that the opposite of an angle, we're looking at that referenced angle to find the opposite. And we call that referenced angle the theta. So here is our referenced angle, and opposite of that, it's not touching it, is this side right here. Here is the other acute angle that we reference as theta, and opposite of that is this side. Adjacent means next door. It is next to the angle being referenced. So here's our theta. Notice that this is the adjacent. The other thing is notice it's touching our hypotenuse. So our adjacent side, that acute angle that touches the hypotenuse, is always this angle, right, this side right here. Here's our theta. Look, it's touching the hypotenuse again. So that's our adjacent. It's next to our referenced angle, our theta. Let's label what we recognize from our unit in circles. So here we have a circle. Notice that right here is our tangent. Our point of tangency. Our point of tangency makes a 90-degree angle. So that gives us a right triangle when we use our radius. Then we have another line here, which is also a leg. And check it out, we have our hypotenuse. Now our hypotenuse is part of the radius, and then it goes ahead and it connects to this tangent line right here. So here's some key concepts when we move into trigonometry. The sine, cosine, and tangent of any acute angle of a right triangle can be determined by using a calculator. This illustration summarizes how the ratio of sine, cosine, and tangent of angle B, so right now we're going to use angle B as our referenced angle for a few of our slides. It's going to relate to the circle with a radius of unit 1. So right here, this is going to measure 1. So we have our cosine, here, which remember is our x. We have our sine here, and then we have another radius going right up here. That's our hypotenuse. And then this is our tangent line. Our referenced angle is known as theta. Let's go ahead and label these. So here's our referenced angle. We've gone ahead and marked that as our referenced angle. We're going to label each one of these with hypotenuse, adjacent, and opposite. So side X looks like it's right down here. And here's our referenced angle. So it's not touching our referenced angle in any way, and it's not the hypotenuse. That means that it's the opposite. Then we're looking at Y. Here's Y. It's touching our referenced angle. It's next to our referenced angle, and it's not the hypotenuse. That means it's the adjacent. And that leaves us with Z, which is our longest line, and we call that our hypotenuse. What do we notice that's different between the two angles? Well, opposite is here and adjacent is here. A trigonomic ratio is the ratio of two side lengths. That means we're going to take one side length and divide it by the other side length. That's what gives us a ratio. So specific to one acute angle, the sides are referenced as adjacent, opposite, and hypotenuse. We just talked about that. The hypotenuse is the side opposite the right angle. So it's always opposite the right angle. So let's go ahead and highlight our hypotenuses really quick. So here's our hypotenuse, and here's our hypotenuse. Did you notice that your hypotenuse did not change? It's always the longest line. It doesn't change. The opposite side is across from or opposite the referenced angle, the given angle, the theta. So that's going to be in this one, in this triangle. Here's our referenced angle right down here of A. This is going to be our opposite. Then our referenced angle is B in this triangle. So this is going to be our opposite. Let's change that to green. The adjacent is going to be right next to our referenced angle. It's going to be touching our reference angle. It's going to be helping us create that referenced angle. Here's our referenced angle A. Therefore, this is our adjacent. So when we want the tangent of a line, the tangent ratio, we can take our referenced angle B and we can divide the opposite by the adjacent. So let's find the opposite of B. There it is. And let's find the adjacent to B. Now we don't want this hypotenuse in here. We want the adjacent. Sine and cosine are the y and x. So if we're looking for sine B, we're going to divide the opposite line length by the hypotenuse. So this time we do want the hypotenuse. So we're going to find the opposite of B, the one that is not touching B in any way, shape, or form. It's opposite from it. So that's going to be DE. And then we're going to find our hypotenuse, and our hypotenuse is going to be our radius this time around. If we're looking for cosine B, we're going to do adjacent over hypotenuse. So let's go ahead and look at B as our reference. Here's B as our reference. We're not looking for the hypotenuse. First, we're looking for the adjacent, and then divide that by the hypotenuse. Notice when you're looking for the cosine, it's the x-axis. Notice when you're looking for the sine, it's the y. The y flies, the x is our flat line. Okay, so let's look at how we do this. What is the tangent ratio of angle B? So we're referencing angle B right here, and we're looking for the tangent. So that means we're going to take the opposite and we're going to divide it by the adjacent. So we're going to do B divided by A. What is the cosine ratio of angle A? So when we're looking for cosine ratio, We want to look for the adjacent. Now we're looking, referencing A. We want the adjacent, so that's going to be this line right here. And we want the hypotenuse. So that's going to be this right here. So that's going to be B divided by C. What is the sine ratio for angle A? So when we're looking for sine, we're looking for opposite, the up and down, the one that flies. So we're going to look for opposite to angle A. There, it's not touching angle A. And we're going to look at the hypotenuse. So that means we're going to divide A by C. What could you use to help you remember sine is opposite divided by hypotenuse? Cosine is adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. Can you think of something that would help you remember which lines we use to find the ratio of theta? Let me know if you have any questions on this assignment. You can text me or email me.